The Milky Way is a vast spiral galaxy around 13.6 billion years old with large pivoting arms stretching out across the cosmos. Our home galaxy's disk is about 100,000 light years in diameter and just 1,000 light years thick. Just as Earth orbits the Sun, the solar system orbits the center of the Milky Way. Despite hurtling through space at speeds of around 550,000 mph, our solar system takes approximately 250 million years to complete a single revolution. Do galaxies, including our own Milky Way, orbit anything in the universe? Have you ever wondered if the Milky Way, our cosmic abode, follows a celestial path in the universe's grand theater? It's a question that sparks curiosity about our place in the cosmos, but it can be perplexing without a clear guide. You might be intrigued, but understanding the Milky Way's movements, its orbit, and the cosmic dance it engages in can be challenging. It seems like everything orbits something in space. Moons orbit planets, planets orbit stars, stars orbit the centers of galaxies. But beyond that, things get a little harder to visualize. Do galaxies, and specifically the Milky Way, orbit anything? To answer that, we first need to know how orbits work. Consider two objects orbiting each other. Those two bodies exert a gravitational pull on each other, keeping them bound together. The objects orbit their common center of mass. If you could shrink the system, the center of mass would be the point where you could balance it on your finger. But in the case of the solar system, or Earth and the Moon, one of the objects is much larger than the other. The center of mass ends up lying inside the larger body, so the larger object doesn't move much, and the smaller object moves on a roughly circular path around the bigger one. At larger scales, things get a little more complicated. Our galaxy is part of a collection of galaxies called the Local Group, which includes the Milky Way, the Andromeda Galaxy, a smaller spiral galaxy called Triangulum, and several dwarf galaxies, including the Large and Small Magellanic Clouds. The Milky Way and Andromeda are the two largest objects in the Local Group. Because their masses are comparable, the center of mass lies between the two galaxies. There's nothing significantly larger than either galaxy nearby, so the two end up orbiting each other. But the Milky Way's orbit isn't circular or elliptical like the orbits of planets around the Sun. It's going to be weird to say if the Milky Way is orbiting around something, because that kind of implies that there's a bigger object. Instead, both the Milky Way and Andromeda are on mostly radial orbits. Imagine the gravity of two things pulling on each other, and they're not moving in any way other than the gravitational pull. They will just move directly on the line towards each other. That's a purely radial orbit. The Milky Way's orbit isn't perfectly radial because there's a bit of sideways motion between the two galaxies. Their mostly radial orbits toward each other mean that the Milky Way and Andromeda will eventually collide some 4.5 billion years from now. Individual stars likely won't crash into each other because of the huge distances between them, so the galaxies will pass through each other and separate again, but not for long. The galaxies will then turn around and come back together. And over the course of hundreds of millions or billions of years, they'll actually merge together into one big galaxy. The gravitational interactions will likely jostle the stars in both galaxies enough to make the combined galaxy an elliptical galaxy, rather than a spiral one like the Milky Way and Andromeda. The merger could also heat the gas along each galaxy's spiral arms enough to form new stars. Orbits on scales larger than galaxy groups are even less defined. But we certainly know the Local Group is moving. The Local Group is being pulled toward the Virgo cluster, which contains several hundred galaxies and lies about 65 million light-years away. But the Local Group will never make it there, because the expansion of the universe is pulling the Milky Way away faster than the gravitational pull of the Virgo cluster is drawing it in. The Milky Way is influenced by the gravitational interactions with other galaxies in the Local Group, particularly the Andromeda Galaxy, as they are on a collision course with each other. So, the Milky Way's motion is influenced by its central black hole and the gravitational dynamics of its galactic neighborhood. Thank you for watching. If you've enjoyed our videos, subscribe to our channel for there's more to come.